Okay, so welcome back to another video. So here we have a definite integral from the square root of 2 divided by 2 to the square root of 2 of the natural log of x times sine of the square root of x times x plus 1 divided by x times the error function of that same input, then dx. So knowing when you see integrals like this, you would think that we would need to utilize a combination of definitions and, identities dealing with natural logs, the trigonometric functions for sine, or even with the error function itself. But seeing how we have the title and how long this video is, this actually can be solved very quickly. So depending on your definition of quickly. So I don't want to give too much of the steps because, again, this can be solved quickly. I can just explain everything in just one go rather than outlining the process of how do we do each one, as I'll explain everything just as quick as it can. But this is actually I wouldn't say easy, but rather it's a quick integral to solve without having to overthink things so, overwhelmingly, feeling so overwhelmed. So other than that, let's actually just jump right in. Let's start off with it. We can actually perform a u sub. So I'm going to let u equals 1 over x, and it's also worth noting that I will call this entire integral capital I. So if I solve for u on its own, then that means I'm going to get that x is equal to 1 over u. Then if I differentiate both sides, I have that dx is equal to -1 divided by u squared, then du. So capital I, and then we have to change our bounds for this. So for new bounds in terms of u is that the top bound is going to be the square root of 2 divided by 2 just by substituting this back here and simplifying it out. And then in the bottom, it's going to be the square root of 2. So as you can see that we have to switch the bounds already, since this is the smaller number acting as the top bound and a bigger number acting as the bottom bound. So we substitute everything for x in terms of u. So I have ln of 1 over u, then multiply with sine, then substitute the square root of x for square root of 1 over u. So that's 1 divided by the square root of u, multiply with 1 over u, add this with 1, and then divide this by 1 over u over here. Then on the denominator, so that means I'll have a 1 over u, then multiply with the error function of that same input just like that. So 1 divided by square root of u, multiplied by 1 divided by u plus 1, all this being divided by 1 over u. And then lastly is to substitute our dx differential, which this is multiplied with -1 divided by u squared, then multiplied with du. So as we see that we can switch the bounds, that becomes negative, and then that negative sign over here will cancel. Taking a couple steps further, I'm going to distribute the u squared into here, so that'll cancel. So we're just left with u times the error function. And another step further is that not only will I multiply the u to both the top and bottom, that I'll actually multiply the square root of u for both the top and bottom as well, since we don't want, the square root being acting as under the denominator. So we actually simplify all this out. So that means I'm going to have the square root of 2, then the square root of 2 divided by 2 as the bottom bound. Then so far I'll have the natural log of 1 over u. Then this is multiplied by sine of. So actually what's nice is that if you perform all the simplification out in the bottom, you're actually going to get the exact same inputs from the given, except everything is in terms of u. So we have the square root of u times u plus 1. Originally it says 1 plus u, but it's addition, so we can just switch that around. Then divided by u. On the bottom, so we'll have, this is going to be u, then times the error function of the same input over here, square root of u, then times u plus 1, then divided by u, and then multiplied by du. So now how do we proceed forward here? So let's actually apply some natural log properties. We have a natural log of 1 divided by u. So if we use that property saying with the division, so that's the subtraction of natural logs. So in other words, I can be rewritten as the same thing as a difference of natural logs, well, difference of integrals with applying that natural log. And then you'll notice that ln of 1 obviously going to approach 0. So let me actually write this out in full by also applying the linearity to it. So square root of 2 divided by 2. So first we have the natural log of 1 and then multiply it with this everything over here. Then afterwards we can just take the subtraction, do the same thing over here, square root of 2 divided by 2. So then this will become the natural log of u, and then same thing as the above. So sine the square root of u plus 1, and then divided by u. On the denominator is u times the error function of that same input, u plus 1, and then u, then multiplied by du. And then as mentioned, that ln of 1 is going to be equal to 0, so that means this is just going to vanish and we're left with this. So I indeed is just going to equal this. And what's nice is that we set that I is equal to the given formula, or the given integral. then after performing all that u substitution, we actually get another form just like this. What's nice is that the integrand actually matches. So what happens if I were to take double of I, so 2 times I, so I can actually just take the first integral, then subtract it with, and well, not subtract, take this first integral, then add this with this integral, which is a subtraction over here. And of course, this is a dummy variable, doesn't matter which variable we use. It's actually the same integrand, and you'll see that indeed that 2i is equal to this I over here, then subtract with this I, and so indeed that we have that our final answer is that this is actually going to equal 0, which concludes the final answer of our given integral. Solve quickly just like that. So yeah, that's pretty cool if you ask me.